right, ladies and gentlemen, welcome to today's lesson about correlation and causation. I want you to take a moment to look at this wonderful graph. I'm so glad that someone on the internet made this because it just brings so much joy into my life. And I want you to look at this and see what pattern is there. What story does this graph tell you? And I really wish that I could be there having this conversation with you about this wonderful graph, about how as the Internet Explorer, I don't know if you use that, but that's a internet browser, as the market share has decreased, the murder rate has also decreased. And so really, according to this graph, it lets you know that Internet Explorer was making people murder others, right? That's clearly what this graph is saying. But I want you to realize that that's ridiculous. Just because it's a graph that someone made on the internet and posted, that doesn't mean Internet Explorer was making people murder. That's not what that is. This is something called a correlation, right? We've been talking a lot about correlation, but this is not causation, right? Internet Explorer is not causing people to murder. All right, let's look at another one. This is a fun game I like to play. Look at the graph. We got fresh lemons imported to the U.S. from Mexico, and then we got total highway fatality rate, right? The number of lemons, the amount of lemons we're importing is growing quite a lot. And then we got our highway fatality rate is just totally decreasing a lot here, right? You can tell that it's going down. And there's also this very important R squared here. All right, this is saying that the correlation coefficient is really high. This is R squared, not just R, but your correlation is quite high on this. It's a very strong negative correlation. And I want you to think about are lemons being imported from Mexico saving people from dying in violent car crashes? And I hope you said no to that, but if you said yes, you can imagine like dozens of little lemons like hopping in front of trains and semis as they careen towards minivans. That's not really happening, right? These lemons aren't causing fatalities to go down. They just happen to be going up while the fatalities are going down. That's called a correlation, not a causation. All right, and there's a lot of these, right? So I'll take a moment. You got honeybee production, honey producing bee colonies in the U.S. versus marriage rate in Vermont, right? This is a strong positive correlation, and this is real data, by the way. This is not like made up graphs, kind of like the last ones. Actually, this is probably real data. Anyway, all right, this is directly from the census. And so, you have the marriage rate here. You got bee, honey producing bee colonies, right? And they just have this really strong positive correlation, right? Honey producing bee colonies is not causing the marriage rate to fluctuate in Vermont. So this is, things are correlated, right? They're following a similar pattern, but one's not causing another to happen. All right, here's another one that I found that I thought was delightful. All right, UK citizens who immigrated to the U.S. strongly correlates, right? I got 0.8283 correlates with U.S. uranium exports, And so this kind of gives the feeling that if the U.S. is kind of just exporting uranium, and then we're getting UK citizens moving in, right? We're just like, you guys can have uranium, and then we'll take citizens from the UK. We'll take some from Britain, we'll take some from Scotland. We'll just kind of take a few of them, and we'll send out some uranium, right? That's not what's happening. This is just a correlation. It's not a causation, right? Us exporting uranium is not causing UK citizens to be like, all right, let's move to the US, and then they do it. And that's not how it's happening. Let's see, per capita consumption of cheese and total revenue generated by golf courses, right? We eat more cheese, and so golf courses earn more money. That's not an actual causation, right? This is not causing the other thing to happen. Let's see, money spent on pets in the U.S. and number of lawyers, right? We buy more pets, so we need more lawyers, obviously. But yeah, this is kind of the big lesson of this assignment. This is why you're doing it. You need to know that correlation, just because two different data sets are following the same pattern, doesn't necessarily mean one is causing the other to happen, as you saw in these previous examples. Okay, and so let's dive into your actual assignment where you have to, you'll do some graphing, you'll do a little bit of getting line of best fit stuff. And I just want to point out on this section, you're going to get the equation of the trend line. That's line of best fit. You'll need to put in your data in your calculator. You'll probably use the online one, or you can use a graphing calculator, and you'll describe your correlation. You are supposed to graph this data over here. I want to point out these x values, these are going to be x's, only range from 29 up to almost 33. And so here you probably want to just count by, like, do a little squiggle here, and we got 29, and then count up so you get all the way up to 33. Yeah, so something like this down here. So every tick mark is 0.5 as you go across. And then, let's see, these go from about 300 to a little bit over 800. So you probably want to count by hundreds here. 100, 200, 300, 400, 500, like that. And so you'll be able to make your scatter plot up here. So hopefully that gives you some guidance in getting your scatter plot going. So that should help you get the scatter plot on there. But I do want to jump to down here. So based off the data, if we want to reduce the number of people being entangled in their bed sheets, which is a horrible, horrible thing, what do we need to do? Well, it's strongly correlated with our per capita consumption of cheese. So really, according to this data, we need to eat... Whoa, hold on. It's got a strong positive correlation. So we need to eat less cheese. Us not eating cheese is going to save people from their bed sheets. So that's really what it says, according to the data, right? Quote unquote, according to the data. But what else could possibly account for the relationship between the two quantities? Well, just by nature of having more people living in the U.S., there's going to be more of these freak accidents, right? So the amount of people being entangled in their bed sheets is going to increase just as the population gets bigger, right? If you go from 1 million to 100 million people, the amount of weird, kind of these weird ways that people passed away is going to go up as well. And so just increasing the population is going to increase that. And then the per capita consumption of cheese, right? We, as Americans, like cheese, and we're liking cheese more and more, and so we're including it on more things and more ingredients for things. And so, it could be a marketing ploy for cheese or but yeah, this is just increasing the population, increasing our connectivity would account for both of these two quantities going up. And so that's things you could write down here. But let's finish up by just mentioning that you definitely need to know that just because correlation is there, right? You can have a really strong correlation. That is not the same thing as one causing another, right? Not the same thing as causation. So go look on your assignment. It's got a bunch of weird things with strong correlations, and you should look at that and realize that one is not causing the other, and hopefully you have a good time with it. Good luck.